and welcome to Jamb's online tutorial. I am Tutor Folarami, and in today's class we'll be discussing the concept of wave. And I believe this is a very common topic in physics for UTME students, for candidates writing Waec, and I'm sure you'll learn very well. Before we go into today's class, I would advise you to get your headphone just to make sure you listen attentively all through, and you don't need to rush this video and calm down to learn everything bit by bit. So we'll be moving from definition to classification to properties to parameters and to all other concepts of waves: sound wave, light wave, water waves, and the likes, and progressive waves also. So let's go to class. Alright, so today, from the definition of wave is defined as the disturbance, right? It is defined as the disturbance or a medium that carries energy. So any medium that carries energy with it, which is a form of disturbance or movement of any substance, is called a wave. Now, we can classify waves in different forms. We can classify wave based on the kind of movement it is having or the mode of propagation. So the first thing is, by classification of wave, we said wave is a disturbance, right? So if we are to classify wave by their mode of propagation now, we have two different waves. We have the mechanical wave, and also we have the electromagnetic waves. So first thing you need to remember is that under this mechanical wave, they are the one that requires a material medium for their propagation. That means any wave that uses a particular medium for movement is under mechanical wave. Example is your water wave. Your water wave requires a material medium, so therefore it falls under mechanical wave. We also have waves on string. Since it is on a string, it is using that string as its medium of propagation, so it's under mechanical wave. We also have our sound wave. Now, always remember this: everything under elements under electromagnetic are X-ray, light rays, gamma ray, all other rays, gamma, beta ray, alpha ray, and the likes. They are all under electromagnetic wave. And how do you remember them? Electromagnetic does not require a material medium, while mechanical requires a material medium. And the second thing, which is the second kind of classification, is their the second type is using the kind of the direction of propagation. This is the second type, using direction of propagation. For direction of propagation, it is either transverse or longitudinal. That's how we can classify our wave in another way, that we have transverse wave, we have longitudinal waves. So the first thing is, you should know that for transverse wave are those waves that move perpendicularly to their direction, and when you hear the word perpendicular, just always have that in your mind, that they are moving 90 degrees to. That means if the first wave is going like this, the second one is going like this, that means there is an angle 90 between them. While that of longitudinal are those waves that move this is perpendicular, this is parallel. So once you hear the word parallel, that is 180 degree, are those waves that moves in 180 degree to the other ones. Do you understand it now? So for transverse wave, we can have all this electromagnetic wave. Everything under electromagnetic wave is a kind of transverse. Do you get that? While for longitudinal wave, we have different ones. So under this longitudinal, we have the sound wave itself, and particularly light waves. Those are under longitudinal. So if we look at the classification now, in summary of everything, we have two different kinds of classification. That is the mode of propagation and the direction of propagation. For mode of propagation, we have mechanical and transverse. Requires a material medium without material medium. While that of using the direction of propagation, we have transverse and we have longitudinal. I believe this is very much clear now. So we also have some other concepts under this longitudinal. So under longitudinal, we can have something called compression and rarefaction. So compression is like you are from the word compress. That means you are bringing everything together, and that is why longitudinal waves is a form of sound, because sometimes your sound can be compressed, and that is for the compression now. This is the region of high density, while for rarefaction, that is the region of low density. I believe that is clear. All right, coming back now, we have the general properties of wave. So for general properties of wave, we have basically 5 general properties of wave. Always remember these 5 general properties of waves. This is general, not particular. So if we are talking about particular properties for each wave, then there are some that would not work for everybody. Do you get? The number 1 is reflection. Reflection of wave. Number 2 is refraction. Refraction of waves. Number 3, we have interference. Interference. Number 4, we have diffraction. Diffraction. Yeah. So we have diffraction, and the last one we have polarization. Diffraction. And number 5, we have polarization. So now I'll break everything down into simple terms. The first one, reflection. The reflection is the sending back or the bouncing back of a wave where it hits an hindrance. For instance, if you have a water flowing towards this part and there is a brick wall here and there is another way on this side, the water would have to change its direction, whereby reflecting that wave towards another part. That is where we talk about the bouncing back, or the changing of direction of a particular wave after hitting a particular hindrance. I believe this is clear. So we also have up to the refraction now. The next one is refraction. So refraction, that one is the bending. So for instance, let's say we can also use water as illustration. There is a water stream here and there is something hindering it here. It will just have to like bend and turn past the hindrance. That is refraction. Refraction is the bending of waves as it moves from one medium to another medium. For instance, water medium to air medium, or air medium to glass medium. It can be any kind of medium. Do you understand that now? The third one, the interference. This is also known as the superposition of waves. And when we're talking about superposition of two waves, that is when they are in phase. But in that interference, you can have 2 different cases. We have the constructive interference and we have the destructive interference. I believe this is very much clear now. Sorry about that. I had to energize. Alright, so let's continue. From diffraction now. From diffraction. This is also the bending of waves around an obstacle. That is diffraction. Remember refraction. Refraction is the bending of waves as it passes one medium to another. Now be clear with the difference between refraction and diffraction. This, as it moves from one medium, this one requires a medium for refraction. As it moves from one medium to another medium. While that of diffraction is that it bends as it sees an obstacle. Bending around an obstacle is diffraction, while bending because of one medium to another is refraction. I believe that is clear. And the last one, which is polarization. Coming to polarization, you see some places they will spell it with Z, while some textbooks will spell it with S. So everything is still the same thing. So now, oh God, I'll have to cut this part.
Action.
Now to polarization. Just like I said, polarization is making a wave moving in different position or many positions to move just in one phase. For instance, if we have a wave moving towards this way, we have another one moving towards this way, and we are trying to make these three move just to one phase. Let them move in just one line. That is what we know as polarization. And for polarization, we can use different instruments. We can use filter, we can use some other polarizers just to make sure that all our waves are moving in one direction. I believe this is very much clear now. All right. So moving on. We also have another concept of wave, which we know as stationary waves. Alright, so to stationary waves now. Stationary wave is formed when two equal waves but are opposite. For instance, if I have this wave going towards this direction and I also have this guy going towards this direction, these are two equal waves moving in opposite direction. Stationary waves are not moving together, they are moving in opposite, right? And are superimposed. Remember what we call superposition then? That when we have two waves moving in phase with each other, that means they are moving towards the same place. But in this case now, we have two different waves moving in different direction and they are what? Superimposed. For instance, if we were to draw a diagram, let's say we have this wave and we also have another one like this. These waves now, these two waves, we can say they are superimposed because they are moving in opposite direction. Let's have this. Let me just draw this to represent the direction they are moving towards. Oh, this should be facing this. This should be facing out. I believe this is very much clear now with the diagram. So now the first thing you should always remember is that we need to touch some parameters before we go into exclusive explanation of stationary waves. So this will lead us to parameters that are useful.